Good morning to everyone. Today we are going to discuss about three-phase grid-connected inverter design with PI control using MATLAB for 9863 grid integration course. So without any further ado, let's go to the today's outline. In today's outline, we are going to discuss about a brief introduction about this project, a problem statement, literature review, methodology, background of the study, results summary, and a conclusion. The development of the society and the economic depends on the energy technology. The classic power grid system is made up large interconnected measures. The facts that such a network is dependent on large central situated power generation facilities that are linked to high voltage transmission line and supply electricity to medium and low voltage distribution system is one of its disadvantages. The typical power grid, as shown in the figure, permits centralized electrical power generation where electricity is generated close to the energy source, such as hydro dams, and transport to clients who are far away. During the transmission, a sizable portion of electrical energy is lost. Therefore, it's recommended that power generation and consumption are closely together. Because of the projected exponential growth in the energy demand and the depletion of fossil fuel resources, renewable energy sources are crucial in the current power landscape. The most common grid-connected inverter architecture is the three-phase half-bridge voltage source inverter. Space vector pulse width modulation with which has a high voltage consumption ratio and a straightforward to implement digitally. It's utilized with three-phase VSI. The main focus of this work is on the design and the implementation of the current controller for three-phase voltage source inverter. A sine wave that tracks the grid voltage or one that has the same frequency and phase as grid voltage in is what the current controller aims to make sure the inverter output current is. Moving to the problem statement, the power supply in Sri Lanka has improved and rise in recent years, but the demand has continually outpaced supply, resulting a severe energy shortage in the years of 2020 to 2022. Wind energy has emerged as a viable form of renewable energy due to the economical feasibility. The installed wind power capacity in Sri Lanka was 500 megawatts as of March 31st, 2022. However, because the wind is dependent on the area and season, it wasn't very dependable when power electronics were still in their infancy. Wind energy systems are now on one of the trustworthy source thanks to the interface of power electronics. However, stability and the synchronization with the utility grid still have certain issues. These issues have been resolved by using new control algorithms to switch the PWM base voltage source inverter that is employed in it. In this project, an effort is being made to enhance the control of grid-side inverter. Moving to the literature review. For managing single phase power factor correction converters or as well as a DC to DC converter, average current controller has been frequently used. The benefits of using average current controllers are a high gain current control amplifier utilized, error is reduced, large noise margin, absence of external RAM correction. Implementing a current limit is a simple, effective tracking of average current mode of control. Small signal modeling, which would be based on changes in the surrounding modeling, is required to construct a current average control for an inverter. This approach modifies the circuit itself rather than the equations that comprise it. To create a time invariant circuit, the converter switch are replaced by voltage and current source. The conversion waveforms are then combined across one switching interval to eliminate unwanted switching harmonics. Study shows that Sri Lanka, with a plant factor surprising 32% in some locations, has better potential of generating power from wind energy. The Wind Power Association of Sri Lanka claims that the capital cost of moderate wind power station is higher than 254 million rupees per megawatt. Despite that, the factor that establish a wind power plant requires significantly less time than installing a hydropower plant. At certain locations, wind flow is very dramatically during the course of the day. Wind is not steady resource. Due to the wind's unpredictable behavior, the Ceylon Electricity Board has been forced to temporarily cease the further electricity absorption of wind sources. Given the current status of Sri Lanka solar power facilities, from the 2020 goal is 7 years is already a challenge to fulfill. Only 1.4 megawatt installed in 2 pilot power plants in Hambantota. There are still many challenges to address in order to accomplish the stated target. Even its temporary clearance has been given to reach 52 megawatt of installed capacity. High oscillation in the output of power owning of fluctuating solar light at a specific location with will have an impact on quantity that can be observed by the national grid, much like the wind industry does. Another obstacle to the growth of industry is demand of money. Despite the factor that the sunlight is free, capital is not. According to the certain investors, the cost of financing for solar might approach 269 million per megawatt. Based on the current cost projection, it will be challenging to attract investors in order to use solar power to produce energy to feed the national grid. In addition to these problems, the necessity of for a lot of land and generate enough electricity will be soon drive up the price of solar energy. More into the methodology, this research provided a three-phase grid-connected inverter architecture using PI controls. The reachable rationale of the associated work done for the proposed study are described in the first chapter of the project. When it's finished, the single-phase inverter model with the LC filter and resistor load are created. Following the model, the construction of the current and voltage control loop, both plots with used to monitor the stability of the system. The modeling of three-phase grid-connected inverter, which requires two-phase of modeling, is covered in the following chapters. Power stage modeling is one thing, and from the power stage model, a tiny signal model based off some perturbed and observed in produce. The design of the control loop for both voltage and current is shown in the next slides, along with the transfer functions that were produced for the stability research. The outcome of the simulation being run in MATLAB-SIMULINK environment. Move into the background of the study. At the inverter output, a filter is required because the inverter signal is simply the DGM signal. The only thing that relies in large is amplitude. As a consequence, this sensor detects the switching frequency harmonics and multiplies. The output filter of the inverter is an LCL filter. The ability to function at a low switching frequency, benefits in the filter size or over all those filters, low voltage drop and enhanced damping over those filters are the key arguments of choosing this filter over classic L and LCL filter. The mentioned figure describes the three-phase converter equivalent circuit linked to the grid. Moving to the results and summary. This is the simulation for the system. The data of this research was taken from the wind source private limited Sri Lanka. The power is 10 kVA. Voltage for the grid is 400 volt. DC voltage is 780 volt, and the switching frequency is 10 kilohertz. Moving to the results, this is the case number one, which does not have any current control. So as it does not have any current control, there is some variations, some harmonics over here. So as you can see, this is not like in a perfect condition. So moving to the next slide shows. On this slide shows the case number 2, which has a current controller. So as you can see in the figure, in the receive side you can see there is there is no any harmonics or any distortions for the current, so it has like a proper diagram over here. Moving to the conclusion, this study calculates the LCL filter parameters necessary for the three-phase inverter and the grid integration equalization of phase voltage and phase angle, phase sequence and frequencies achieved under parallel coupling conditions. Furthermore, everything is completed and the system is operational. The LCL filter, in addition to the decreasing high order harmonics, enable quick overlay of grid inverter voltage and current improvements to the system, DC bus voltage management and crucial algorithms of the inverter grid connection has been proposed in subsequent stage of this study. Thank you. Have a good day.